Okay. Okay, so you're all very welcome to this module on the spirals of creation. This is an extremely interesting topic. It's a topic that effectively recounts the whole story of creation, right from the emergence of creation from source, all the way through the different processes of creation, right out into the world we see around us, encompassing all its polarity, all its division, all its conflict. All of this is reflected in the story of the spirals. Now, as we go along, if you find the volume too low, we can bring it up a bit or whatever. It's okay, is it? Yeah, everybody can hear? Yeah. And Jim is the ringmaster at the back. We have to obey Jim's orders. Thanks, Jim. I think we're okay now. Now, this module is part of a series of modules that the speakers have requested. There's a sequence of modules describing the structure of the spirals, the theory behind the spirals, how they emerge in creation, how they influence creation. So there's a sequence of modules or there's a particular module referred to as the comparison between the crystic structures, the crystal spiral, and associated crystal structures on the one hand, and their distortions in terms of metatronic science on the other hand. So there's a desire to establish a clear comparison between the two and to put that out there. Now, it's intended to continue on from that with another module that will look at the implications of the different choices, the implications of the use of the crystal spiral versus the use of the metatronic spirals and their associated sciences. So there is another module in preparation, or another sequence of modules in preparation, which will look at the implications, that will look at the history, some of the consequences, some of how this has influenced the world that we see around us at the planetary and at the cosmic level. So there are other modules coming in this series. Also, there's quite a bit of new material, or there's a certain amount of new material in this module, and there hasn't been a lot of time for it to get properly reviewed. So please treat this module as a work in progress. The speakers may wish to change some of the information to adapt it or to correct it in various ways. So please treat it as a work in progress. Now, we move on. We start, first of all, with the crystal spiral. We will then outline the formation of the metatronic spirals, the golden mean spiral, and the Fibonacci spiral. We will cover a certain amount of science along the way. We'll look at we'll cover a little bit of scientific background, a little bit of mathematical background, because in the crystal, the Christiac teaching in the crystal structures. Okay, Pam. Yeah, thanks. In the Christiac science, there's incredible depth, tremendous profundity. There's incredible truth, strength, power, and profundity in the teachings. And if we explore a little bit of scientific background, we can begin to see the incredible depth of these teachings, the incredible power of these teachings. It's absolutely mind-blowing. And a little bit of scientific background will actually give us a broader base to see a bigger picture, a bigger perspective on the richness and the power of these teachings. Now, we start with the crystal, or the Katara grid is the foundation stone for all of the crystic structures. Do you want to see it? You want to see it? You sure? You can take it. Okay. Yeah, sorry. Okay, so all of our stories begin with source, they end with source. Source is the beginning, and source is the end. And it's the source that makes sense of everything that happens in between. Now, the whole story of creation can be summarized very simply in terms of source in its infinite power, infinite integrity, in its infinite creativity and freedom. It brings focus to a particular idea, and in focusing on a particular idea, it creates structure around that idea. It projects consciousness into this structure, and in doing so, it expands the structure. It elaborates it into ever greater degrees of structure, which expand outwards into manifestation. So a source in creating, it has an original purpose, an original design, and an original intent. This manifests as an encryption, This encryption is stored in the foundation structures that impact, that build creation. And one of the key structures where this, one of the key template structures that carries this encryption is the Katara grid. The Katara grid carries the encryption, the design intention or purpose for creation within multidimensional structure. It is the foundation stone on which all structure is built. Now, the processes of creation, there are a couple of fundamental processes in creation, and one of the fundamental processes is the process of expansion. Now, the process of expansion uses the Katara grid as a building block. Just use my monster pointer. I can almost reach it. Okay, so it allows me to stand to one side, so. Okay, so we have our Katara grid, and this is the foundation stone. It's the foundation stone for all of cosmic structure, or for the manifestation of creation within dimensional structure. And it's foundation also for the spirals, for all of the spirals, and in particular for the crystal spiral. A couple of key points to summarize. You're all very familiar with the Katara grid, but it's a quite powerful structure, so it's no harm to remind ourselves of some of the key features. The Katara grid, it encompasses the 12 dimensions of material manifestation. All of the dimensions are interconnected in a grid work of lines. The Katara grid has, like all crystic structures, have an open door through the center for direct connection with source. This is a point of direct connection with source, and all crystic structures have this direct connection through the center with source. Now, we have the lines within the Katara grid, and these interconnect all aspects of the Katara grid with one another, and with, we have a direct source connection through the center. Now, the proportions of the Katara grid are critical because they impact what is subsequently built from the Katara grid. So the key dimensions of the Katara grid are its width and its height, and these are in a very specific proportion of 1 to 2. The height is twice the width. Now, the center of the Katara grid forms a square, and this is important. So the Katara grid has a very regular geometric structure, and this is of critical importance. It's of critical importance to preserve the integrity of that structure. Now, when we come to the process of expansion in creation, expansion uses the Katara grid as the foundation stone for the process of expansion. So we start off with a basic foundation Katara grid. We take it in its original alignment of the Eka-axis on this alignment here. Now, the next stage of expansion, the next stage of growth, involves the Katara grid rotating through 45 degrees and expanding in the process. It expands such that the 9 point of the new Katara grid, the 9 center of the new Katara grid, overlays the 12 point of the previous stage. This sets the rate of expansion as the Katara grid rotates. It rotates through 45 degrees from this position to here, and in doing so expands, such that the 9 center of the current grid overlays the 12 center of the previous grid. This process is repeated in the next stage. We again have an expansion whereby the Katara grid rotates from the vertical position of the previous stage, shown in blue, to the new position 45 degrees further on, and it has increased in size, again, so that the 9 position overlays the 12 of the previous position. Now, if we look at the relationship between this stage of expansion and the original stage 2 steps back, we can see that the current Katara grid has its width overlaying the length of the Katara grid 90 degrees earlier. So this means that when the Katara grid rotates through 90 degrees, it has expanded in size such that the width of the new grid is the same as the length of the previous grid, of the grid 90 degrees earlier. So this 2-to-1 ratio in the Katara grid determines the rate of expansion of the Katara grids. Okay, so we've animated this, this sequence in this diagram here. Here we can see the guitar grids rotating, and as they rotate, they expand in size. We start from the 0 position, we go through 45 degrees stages of expansion, 45 degrees of rotation, and at every stage, we have an expansion of the guitar grid. Okay. Now, to summarize then, the crystal spiral is based on the guitar grid as a foundation stone for expansion within our universe, within our creation. Guitar grids rotate about our common azure point, the central seed atom at the center, and they expand from there. That's where all expansion arises from. Now, the azure center is the center for the, not only is it the center for the guitar grid, it's also the center for the spiral. The spiral is effectively rotating around, around that azure point in the center of the guitar grids. So the spiral at every stage holds connection to this center. Now, this diagram here, it shows the outline of the guitar grids as they expand. So we start from the small yellow in the center, and we expand clockwise through several stages of expansion until we get this big outline guitar grid on the outside. Now, we can see that at every stage of expansion, the crystal spiral, if we join the 12 points of all the guitar grids, they will form a spiral that reflects the expansion from the original guitar grid at the center. Now, each point on the spiral holds connection through the center. If we look at the guitar grids, we can see that the vertical central column of the guitar grids connects each point on the spiral to the center. And in fact, this central vertical column within the guitar grid, it forms an arm for the spiral. It forms the radius for the expansion of the spiral. So every point on the spiral connects back to the center through the central vertical column of its associated guitar grid. So we have direct connection of every point to the center. The radius are these blue lines. The central vertical column connecting the center of the spiral. The center of the guitar grid is also the center of the spiral. All the guitar grids are rotating about a common center point, and this point has direct connection to source. So all the guitar grids have a common center point, and this also is the center point for the spiral. And each point in the spiral is connected through the center point, through the central vertical column of the associated guitar grid, and that forms a radius or an arm for the spiral. So these are the blue lines. You can see them here as they expand outwards from the center to here, to here, to here, and so on, all the way out. So the crystal spiral expands it doubles for every 90 degrees of rotation. And this derives from the width to height ratio of the guitar grid. And this number 2 is the key to the crystal spiral. Now, in between the 90 degrees, we have the 45 degrees expansion. And for every 45 degrees stage of expansion, the spiral increases, the guitar grid and its spiral increases by a factor of the square root of 2. And that's a number we'll talk a little bit about in the next slide. Its number corresponds to 1.414. So the crystal spiral, it forms a smooth exponential spiral that looks the same at every scale from the microcosmic to the macrocosmic. So this spiral goes all the way through creation, from the smallest particuli, subatomic, atomic units, all the way out to the full extent of the cosmos. And it's the same shape at every stage. Now we can look a little bit more closely at the, some of the proportions in the spiral. We started out with a size 1. That's the foundation size for the guitar grid. We rotate through 90 degrees, and we increase the size by 2. So we go from 1 to 2. The next stage of 90-degree expansion, or 90-degree rotation, takes us through an expansion by 2 again, from 2 to 4. The next stage takes us again by an increase in size by 2, from 4 to 8, and then from 8 to 16. So these form the quadrant points on the spiral. So this sequence of expansion by 2 from 1 to 2 to 4 to 8 to 16 and so on. These numbers correspond to the quadrant points on the spiral, and these are the most important points on the spiral. Now, in between the quadrant points, if we divide the 90 degrees into two 45 degrees, we get a set of 8 octant points. And between each of these octant points, we have an increase in size, not by 2, but by the square root of 2. The square root of 2 represents a halfway stage in multiplication from 1 to 2. Now, just to refresh a little bit on what exactly is the square root of 2. If we take a square of side 2, if we multiply two numbers, 2 by 2, to get 4, that's squaring the numbers. The reverse process is going from taking the area of the square as 4 and going back to 2. And that involves finding the two numbers that multiply together to get 4. Now, if we take a square of area 2, we can ask what would the length of the sides be? In other words, what two numbers would I need to multiply together to get the area of 2? It turns out that the numbers I would need to multiply are, we say, 1.414 multiplied by 1.414. So this, it's the reverse process of squaring a number, and it's referred to as the square root. Now, we can get these numbers, we can get this square root. If we take a square side 1, the diagonal on that square, the length of that diagonal is the square root of 2. It's this factor 1.414. So this is the stage of expansion, the degree of expansion that arises every 45 degrees. It increases by the square root of 2. Now, the square root of 2 represents a halfway step. In other words, I go from 1, multiply by the square root of 2 by 1.414, multiply it by that same number a second time, and I get 2. So it's a halfway step in multiplication between 1 and 2. Now, we can see some of these crystal proportions in action in the cosmic structure, and specifically in action in our local Vecca universe. Here, we have a representation of our local Vecca universe with its Eka core, the outer Akasha, and the 4 Vecca quadrants. Now, if we look at the size of the inner Eka, it's represented by this small red Katara grid. If we check what is the proportion between the Eka core and the outer Akasha, we find that the size relationship between the two is 8. In other words, the Akasha is 8 times bigger than the Eka core. Furthermore, the Akasha can be regarded as having rotated through 3 stages of 90 degrees, say from there to there to there to there. So it has gone through 3 quadrants of expansion along the crystal spiral. It's gone through, rotated through 3 90 degrees and expanded by 2 3 times. So by 2 by 2 by 2 to give us an 8-fold expansion. Also, if we look at the relationship in size between the Eka core and the quadrants, or sorry, the Vecca quadrants, we can see that if we take the Eka core and rotate it through 45 degrees, through 3 stages of 45 degrees, we go through 3 stages of crystal spiral expansion. We go through 45 degrees once and a root 2 expansion, go through 45 degrees a second time and a third time. And we get an increase in size of 2 by root 2. In other words, that's roughly 2.8 times. So the Vecca quadrants then are in this exact crystal spiral proportion. So we'd say we can regard this Vecca quadrant as having rotated from the Eka through 3 octants of crystal spiral expansion. Likewise, we can regard this quadrant as having come through 3 octants of expansion from the Eka core. Now, the Eka can be regarded as, in fact, it constitutes 2 Katara grids, 2 12-tree Katara grids overlaid on top of each other. So there are actually 2 Katara grids composing the Eka. So we can regard the other quadrants as having derived from similar rotation of the other part of the Eka core. So we can see that the Vecca universe structure is in strict crystal spiral expansion. The proportions are determined by the crystal spiral. Sorry, too far there. Okay, there's a slide missing. I'll just summarize. No, it's okay. Just skip that. Okay, so that summarizes the construction of the crystal spiral and some of its geometry and some of its significance. We will come back to some of the significance of it in another context a little bit later. We'll now move on and we look at the golden mean spiral. How did this emerge? Where did it come from? Okay, so first of all, we have to ask the question, what is the golden mean? We get the golden mean as follows. If we take a line and divide it in proportions such that the whole line lies in proportion to the larger part as the larger part lies in proportion to the smaller part. If we divide the line in that proportion such that the whole is in the same proportion to the bigger part as the bigger is to the smaller, we get a certain ratio between these, or a certain proportion between these parts. This proportion is represented by a number. Once we do a bit of math on it, we get a number that comes out as 1.618, and this is referred to as the phi number, phi, the Greek letter phi, and this is referred to as the golden mean. So when we divide the line in the golden mean ratio, we get a series of proportions such that when we step up from the smaller to the bigger in this proportion of 1.618, we get the step up from the smaller to the bigger portion is the same as the step up from the bigger portion to the whole. Okay? So the critical characteristic of this golden mean ratio is that the two portions are what we're effectively doing is we're splitting a whole into two portions such that there's a fixed ratio between them. This ratio is given by this phi number, 1.618. It's very easy or relatively easy to work out some of the math on this, and it comes out as the number specifically is the square root of 5 plus 1 over 2, and we get it as follows. If instead of taking the square with sides 1 by 1, if we take a rectangle into proportions of 1 to 2, then the diagonal on that rectangle is the square root of 5. Okay, so if we add the square root of 5 plus 1 and divide it by this, that gives us the phi ratio, the golden mean ratio, which is the basis for the expansion of the golden mean spiral. Now, this number, 1.618, it's heavily associated with the number 5. And it's present in all regular 5-sided figures. For example, in the pentagon. For example, if we take the width of the pentagon, the relationship or the ratio between the width of the pentagon and one side is this ratio of 1.618. It's this phi ratio. Likewise, it's heavily present in the pentagram. You know the 5-sided star you have, what is it, 50 of them in the American flag. So it's all over the place here. Yeah. So the 5-pointed star, the pentagram, which is a very common symbol, that encompasses this number phi, this ratio 1.618. Also, it's interesting to note the correspondence between the sound tones. We start with 5, then we have this, from 5, we build this ratio, 1.618, and we call it phi. And that in turn leads to the Fibonacci. So we have the similar sound tones coming through all the numbers. We have 5, phi, Fibonacci. So the same pattern, the same resonance is traveling through all of them. Now, all of the numbers have their own, numbers play a very important role in creation. They have personality, they have consciousness, like they're conscious entities, and each number plays a specific role in creation. 5 is a particularly interesting number. It's a very powerful number and a very enigmatic number. And because of its power, it's also the number that has been most abused. It's heavily abused 5 in its original form is a natural and very powerful number, but it has been heavily distorted and heavily abused over history. Now, the critical, phi ratio, the critical characteristic of this particular number is that each number is the sum of the previous two numbers. In other words, the whole of this here is equal to the sum of the smaller parts. So if I take a line of length 1.618, divide it into two proportions so that there's a 1 and a 0.618 here, then the ratio of the whole to this larger part is 1.618. And likewise, the ratio between the 1 and the 0.618 turns out to be this 1.618 also. So the whole is the sum of the two smaller parts. So this is a key characteristic of the golden mean ratio and the golden mean spiral. It derives from this construction whereby each number is the sum of the previous two numbers. And if we take any sequence of numbers, if we start with any sequence of numbers, like we take 56 and 90, and if we add them, make the next number equal to the sum of the previous two, and keep doing that, all of the numbers will fall into this ratio of phi, 1.618. Now, going on from the golden mean ratio, the next stage of progression towards the golden mean spiral is to build what's referred to as the golden rectangle. With the golden rectangle, we take the line that we had previously, we take a square of side 1. Now, we split the square in half here, and in doing so, this distance here becomes the root 5 over 2, the square root of 5 over 2. Now, when this distance is rotated down onto the line, we get the square root of 5 over 2 plus a half, and that gives us the phi ratio. So we now have a square of side 1. We have a rectangle added onto it of width 0.618. The length of this large rectangle now is 1.618, and its width is 1. So it is now a golden rectangle in ratio or in proportion of the golden mean that we've seen previously. Not only that, but we also have a smaller rectangle, a smaller golden rectangle here of length 1 and width 0.618. And this is also a golden rectangle in golden mean ratio. Now, if we compare this small rectangle with the big one, the bigger rectangle, the bigger golden rectangle, is 1.618 times the smaller golden rectangle. The two rectangles are in golden mean ratio. And furthermore, the bigger one is rotated 90 degrees from the smaller one. So this gives us, this generates or provides a basis for creating the golden mean spiral. So what we have here is we have a small rectangle, a small golden rectangle, build a square on the long side, and we get a bigger golden rectangle, rotated 90 degrees. Continue that process, build another square on the long side. We now get a bigger golden rectangle again, that is, again, the 1.618 times bigger in size, and rotated through 90 degrees. Continue that process, and we get the golden mean spiral. So again, we start out with our small golden rectangle in the center, add a square to it, and then form a new square on the long side. And then that forms a new golden rectangle. Build a new square on the long side, and that creates an additional golden rectangle. And so on, we continue all the way out. So we end up with a situation where we now have this small golden rectangle with a square built on it, and we have the two together form a bigger golden rectangle. Now, the corners of these squares form the points of the spiral, of the golden mean spiral. We have a sequence of expanding squares. Each square is 1.618 times the size of the previous square. Now, if we take diagonals, if we draw diagonals on these rectangles, a diagonal on the large rectangle and the smaller rectangle, they give us the center of this golden mean spiral, and these arms, these blue arms, form the radii, or the arms of the golden mean spiral. Oops. Now, there's another way we can look at this. If instead of, there's a way that we can look at, another way of looking at this, which gives us much deeper insight into what's going on here. If instead of looking at the squares, the expanding squares around the center, if we look at the rectangles, the golden rectangles themselves, we have here the small golden rectangle. It rotates, it expands, and it rotates through 90 degrees and expands to form a new golden rectangle. That in turn rotates through 90 degrees and expands to form an even bigger golden rectangle, and that in turn again rotates through 90 degrees and expands. Now, if we look at those rectangles, we can see that these rectangles are actually rotating about a common pivot point. So we say we started with that one, rotated through 90 degrees and expanded. We get this yellow rectangle. Take that as the small one, rotated through 90 degrees and expanded. We get a bigger one, and so on. Now, what we can see from this is that all of these rectangles, they're rotating about a common pivot point. The pivot point given by this, the intersection point of these diagonals. So what we have now is, if you remember from the crystal spiral, we had a sequence of guitar grids rotating about a common point, about a central pivot point. That central pivot point is the central seed atom in the guitar grids and forms direct connection to source. What we have here now is a sequence of golden rectangles rotating about a common pivot point. This point is in the same relative position in all of the rectangles. It's about 30% of the way in from one of the corners. The same relative position in all of the rectangles. So we now have a sequence of golden rectangles rotating about a common pivot point, and in doing so, they're creating a spiral. So we're beginning to see the connection back to the crystal spiral. We're beginning to see how this pattern emerged from the crystal spiral. Okay, if we look a little bit more closely at the geometry of this this rectangle, we have the bigger rectangle, bigger golden rectangle. We have the square within it, and we have the smaller golden rectangle. If we draw a diagonal on these, the diagonal on the big rectangle and the diagonal on the smaller rectangle, this gives us the pivot point for the golden mean spiral. And these green lines represent the horizontal and the vertical axis. And these are the arms for the spiral. Now, the next stage of in the story is the development of the Fibonacci spiral. Now, if we look closely at the golden mean spiral, there's a sequence of numbers emerge from it, and they're referred to as the Fibonacci number sequence. Now, the key characteristic of the golden mean spiral and of all spirals associated with that is that every term is the sum of the previous two. If we take the simplest set of numbers, we say 0 and 1, and we build a sequence of numbers whereby each number is the sum of the previous two. So we take 0 and 1 and combine those to get 1. Combine the 1 with its previous value to get 2. Combine the 2 with the previous value to get 3. Combine the 3 with the previous value to get 5, and so on. We get a sequence of numbers 1, 2, 3, 5, 8, 13, and so on. Now, as these numbers develop, the proportion between the numbers falls into the ratio of the golden mean that we've spoken about previously. In other words, the ratio between this number and this is 1.618. In other words, each number is 1.618 times the previous value, or thereabouts. It's approximate in the beginning, and it becomes more exact as you go out through the sequence. Now, if we use these numbers as the basis for a spiral, we now get a spiral that's similar to the golden mean spiral in many respects, but not identical to it. So instead of working with our rectangles, we start with two inner squares representing the 1 and the 1, build a new square on that, on the sides of those to get 2, build another square on the sides of those, combine the 2 and the 1 to get 3, then combine the 3 and the 2 to get 5, and combine the 5 and the 3 to get 8. So we get a progressive expansion out along this number sequence, which builds a pattern that is very similar to the golden mean spiral. So these rectangles, the smaller and the bigger rectangles, they come into the golden mean ratio, into the golden mean proportion. And furthermore, if we draw the diagonals, we get the same central pivot point. Now, if we look a little bit, if we look at the numbers have a certain story to tell. If we take stages of expansion, and these correspond to the quadrants of expansion for each of the spirals. If we look at the numbers, the expansion numbers for the crystal spiral, we go 1, 2, 4, 8, 16, and so on. And by the time we get out to 24 stages of expansion, we're up in the millions. Look at the corresponding numbers for the golden mean spiral. Again, we started with 1, but each stage of expansion only takes us up by 1.618. Goes to 1.618, 2.6, and so on. So it's a weaker spiral than the crystal spiral. Look at the corresponding numbers for the Fibonacci spiral. We go 1, 1, 2, 3, 5, 8, and so on. Now, the pattern of the numbers is similar to the golden mean spiral, but the numbers themselves are smaller. In other words, if we compare these numbers with the golden mean spiral numbers, we see that they're smaller. And they're smaller by a fixed amount. So the Fibonacci spiral is similar in shape to the golden mean spiral, but is not identical to it. It's a weaker spiral, it's slower. It's a scaled down version of the golden mean spiral, and it is scaled down by a very specific proportion. It's scaled down by a little 72%, or a little over 72%. So if we take the golden mean spiral, scale it down by this factor here, we get a sequence of numbers which are almost identical to the Fibonacci numbers. So the Fibonacci spiral is a scaled down version of the golden mean spiral, and scaled down by a very definite proportion. And we can ask, where did this proportion come, or it's interesting to look at where this proportion comes from. Now, if we go back to our original golden rectangle with its pivot point here, if we section this golden rectangle at the pivot point, we get a new rectangle, a new golden rectangle that is that represents this exact scaling. In other words, this smaller golden rectangle is a scaled down version of the bigger one, and the scaling is identical to the scaling between the Fibonacci spiral and the golden mean spiral. So what this means is, if this rectangle is the basis for constructing the golden mean spiral, this smaller sectioned rectangle is the basis for building the Fibonacci spiral. Okay? So the Fibonacci spiral is a scaled down version of the golden mean spiral, and the scaling is represented by the proportions between this smaller rectangle and the bigger one. So this now is the Fibonacci rectangle. This is the smaller rectangle that creates the weaker spiral, which we know as the Fibonacci spiral. Now, this Fibonacci rectangle has it's in golden mean ratio, and again we can divide it, we can get the square, and we can get a smaller rectangle within it. And we can get the diagonals on those, and we can get the pivot point. This is the pivot point for, this is the center, the pivot point for the Fibonacci spiral. This is the center and pivot point for the golden mean spiral. Now, moving from the golden mean spiral to the Fibonacci spiral does one thing that's of interest. It moves the center. If you look at the golden mean spiral, the center that's pivoting around is very much off-center. It's geometrically, it's not symmetrical. It's off to one side within the rectangle. Now, when we go to the Fibonacci rectangle, we actually pull the pivot point much closer to the center. And we can see the significance of what that does now in the next slides. Now, everything in creation comes from, everything ultimately comes from source, and everything that comes into creation is conditioned by the original encryption, and the original encryption is represented by the Katara grid. So ultimately, everything in creation relates back to the Katara grid at some level, at some stage. Now, we can relate these structures back to the original Katara grid. So we take the Katara grid, and it's bounded by a rectangle. It's in the proportion of 1 to 2. So the rectangle that bounds the Katara grid has this proportion of 1 width, 1 height, 2. Now, if we overlay that with our golden rectangle, and oddly enough, it's easy enough to do that. If we take this line 3 to 7, and if we rotate it, if we rotate it upwards into this position, it gives us our golden rectangle. So it's actually relatively easy to construct a golden rectangle within the Katara grid. Now, what we get now is we have our golden rectangle within the Katara grid. We can see straight away that it cuts off 2 dimensions. There are 10 dimensions within the golden rectangle, 2 dimensions cut off. Now, we're living in a universe at the present time that is conditioned by these distortions, and this is reflected in the fact that scientists presently theorize that there are 10 dimensions, only 10 dimensions within our universe. They don't see the full span of 12 dimensions. So again, this relates back to these distortions. Now, the lower square sits in the lower half of the Katara grid, and the small rectangle, the small upper rectangle, sits in the upper portion. If we draw our diagonals, we get a center point for the golden mean spiral here. Now we can see straight away that these diagonals, they're beginning to afflict the 5 and the 8 centers. Now, what happens if we include the Fibonacci rectangle? Excuse me. Okay, so we now section our original golden rectangle at its pivot point, and we get our Fibonacci rectangle. We can now see that the center point for the Fibonacci spiral is pulling in very close on the central vertical column. It's pulling in on the central vertical column, and it's beginning to afflict the 5 center. Now, we can move this structure within the Katara grid, and if we move it upwards, we get a very interesting alignment. When we move it upwards, the core, this pivot point for the Fibonacci spiral, now aligns very closely with the 8th center. You can see it aligning with the 8th center in the Katara grid. That means that it's directly afflicting the 8th center in the Katara grid. We also see that the rectangle, it's impacting the left side of the Katara grid, the 4, 7, 10 centers, and impacting the 8th center, which is very important. That's the galactic core within the Katara grid. So the part of the Katara grid that is least affected by this particular alignment is the right side, the Amareya passage. Now, finally, if we superimpose the roue-shape pattern, we see that this Fibonacci center is now afflicting not only the 8th center, but the 12th center in the roue-shape pattern. So it's afflicting both the 8 and the 12 centers. Okay, I'll just skip on and skip back a bit. Okay, so what we have here now, this is the Metatronic tree of life. We'll talk a little bit more about it in a minute. But we just want to point out that if we look at the Metatronic tree of life, we can see that the centers that are missing. It's interesting to look at the centers that are missing. The 8 center is missing, and the 12 center is missing. There's a false center created at 5. The central seed atom is out of the picture. There are many, so effectively we have 12 and the 8 centers are removed, and these are the key grid connection points. The 12 is what connects to the next level up in cosmic structure, and the 8 is the galactic core, a very important connection point within the Katara grid. So we see that the 8 and the 12 centers are afflicted and removed. We see that the false center at 5, we have various lines missing. We have the width of the grid is narrowed to 87% of the proper width of the Katara grid. Center 1 is pulled downwards. We get a width to height ratio. Instead of 2, we're getting 2.3. And we also see that the vertical symmetry of the grid is destroyed. So if we take a center point through the central seed atom, or what should be the central seed atom of the grid, look at the upper half versus the lower half, and you can see how distorted they are. They have a false center at 5. If you look at the grid in terms of what's above and below that center point, you can see how the degree to which the symmetry of the structure, the natural symmetry of the Katara grid, you can see how much the symmetry of the structure is distorted. So the vertical symmetry of the grid is broken, and we'll come back to these 2 points in a minute. Now, so what we have now is we have a sequence of progression from the crystal spiral all the way out to the Fibonacci spiral. So if we take the crystal spiral, starting from the crystal spiral, which is the foundation structure of the original creation, if we change the ratio, the original ratio of the Katara grid is 2 to 1. If we change that ratio to 1.618 to 1, in other words, use the golden mean ratio, we end up with a golden rectangle. Rotate that golden rectangle by its off-center pivot point, and we get our golden mean spiral. Now, if we slow down the golden means, if the golden mean spiral is slowed down, which is represented by that scaling we talked about, reduce the golden mean spiral to align with the Fibonacci spiral, with the speed of a Fibonacci spiral, we get the Fibonacci spiral. So what we have now is we have a pathway of connection from the crystal spiral to the Fibonacci spiral. Now, we're not saying that this is exactly how it was done, how the distortion was done, but what it does give us is a chain of connection from one to the other. And that it's of value to have that chain of connection, to know how the two connect, and to see where the distortions came into play. Okay, now to compare the spirals, the crystal spiral has a very regular spiral structure with simple, well-behaved mass. Simple. Okay. It is symmetrical, it is centered, and it's aligned with the Katara grids, fully aligned with the Katara grids that generate it, and it's aligned at every stage of expansion. The Katara grids have a much richer internal structure. Within the Katara grid, you have all the dimensions are interconnected. You have a very powerful interconnection of all the elements of the Katara grid. Everything connects in to the center point, the central seed atom at the center. So you have this rich inner structure by means of which energy can move from the center of the Katara grid out to the different parts of the Katara grid. Compare that with the both the golden mean and the Fibonacci spirals. We're talking about squares and rectangles, which are basically empty. They're lacking in internal structure. So the Fibonacci and the golden mean spirals, they're lacking in internal structure. They have no direct connection to their centers. They need external, such internal structures they have derives from what's happening outside of them. So they're deriving their structure from their external connections. So they need external structures then to get them going. And as they expand, as they elaborate, they're progressively removed from source. Within the crystal spiral, every guitar grid embraces the center and sustains the dynamic for outward expansion from the center to the periphery, and for a backflow return from the periphery to the center. Now, in the early stages of the Fibonacci spiral, it isn't a proper spiral. The golden mean spiral is a regular spiral, even though it's a distorted one. The Fibonacci spiral in its early stages isn't even a proper spiral. It becomes one as it expands, but it doesn't start out as a proper spiral. As it expands, it approximates the golden mean spiral, but only a scaled-down version of it. Now, something that we'll come to in a minute is that just as you have an outward expansion along the spiral, you can also have an inward contraction along the spiral. A proper spiral has the capacity to contract inwards towards the center. The crystal spiral can do it, the golden mean spiral can do it, but the Fibonacci spiral cannot. It's not capable of expanding inwards towards the center because it doesn't start out as a proper spiral. So if you go inwards along the Fibonacci spiral, you stop at 1. You can't go further. It's incapable of converging towards the center. The crystal spiral is much stronger. It expands more rapidly than either the golden mean or the Fibonacci spirals. And even when the golden mean or Fibonacci spirals start further out, the crystal spiral will always overtake them. It is and we can see that on this particular diagram, which Ash has discussed in the FOL workshop. Here we have the crystal spiral and the guitar grids that underlie it. We have superimposed on it, we have the Fibonacci spiral with its associated rectangles, the associated golden rectangles of the Fibonacci spiral. Now, the Fibonacci spiral can start at a stronger point further out in cosmic structure and can expand from there. And that is what is happening at the present time. We're coping with a Fibonacci spiral that is expanding from a stronger position out in cosmic structure. Now, there is a conflict coming into focus between the Fibonacci spiral and the crystal spiral. We're coming into a stage of expansion of these spirals where we have a conflict developing between the Fibonacci spiral and between a Fibonacci spiral and the crystal spiral. Between the periods of, I think it's the 15th and 16th of February 2011 and August, Hetelon in August of 2011, the two spirals will come into proximity such that the Fibonacci spiral begins to exert pressure on the crystal spiral. And the intention of that alignment and of that conflict was that the Fibonacci spiral would intersect the crystal spiral on this axis 7 position in August of next year. The intention is to, or it was designed to break the crystal spiral at that point and to capture its energy from that point. But the intention of the Guardian races is that the crystal spiral will be strong enough to ride through that point of conflict. So we will enter into a period of contention and ultimately into a period of conflict between the spirals. The conflict is focused in the period of Hetelon of 2011. But once you pass through that, the crystal spiral will have override the Fibonacci spiral, and from then on it will expand much more strongly and be free of conflict with the spiral. So we do have a battle going on between those spirals at the present time. Now, just coming back to the Metatronic tree of life, If we look at the a very important aspect of crystal structure, of crystalline structure, and of crystal structures generally is that there's interconnection. We have many levels of cosmic structure, and in the crystal structures, all of the levels interconnect. So such that there is an open flow from through all the levels of cosmic structure. So this means that the Katara grids associated with the different levels of cosmic structure it's important that they can align one with another, so that they can align from one level of cosmic structure to the next. So it's very important that the Katara grids, that their proportions are preserved such that they can interconnect from one level to the next. So for example, the Katara grids corresponding to the Vecca quadrants in our Vecca universe are supposed to be able, it's necessary that they be capable of coming into alignment at the Eka core. So the bottom of one Katara grid must align with the top of the level below it. Now, with the original Katara grids in their correct proportions, the alignments are exact. They all fit, they all interleave, they connect together, and they form open connection. And this is a key element of properly functioning crystalline structure. We have interconnection through all the levels of cosmic structure and open flows between them. Furthermore, we have polarity. We have party cum and party k polarity in creation. And it's very important that the two polarities can come into alignment with each other, that they can interact properly. So this requires this interaction between party cum and party k. In the party chi phasing process, we see that the party cum and the party k elements, they align at 90-degree angles to each other in their maximum expression. So that means that Katara grids associated with the party cum side must be capable of aligning with Katara grids associated with the party k side, which exist or which lie at an alignment of 90 degrees. So that means that the Katara grid must be capable of overlaying its corresponding Katara grid when it's rotated through a 90-degree angle. So because the Katara grid has a square at its center, when we rotate it through 90 degrees and overlay it, they overlie each other exactly. So we get exact alignment between the polarized expressions of the Katara grids. So that's an important aspect of the proper functioning of cosmic structure. Now, if we look at what happens with the tree of life structure, if we try to align these, what do we get? First of all, if we try to align them in Vecca quadrants, they cannot align because they're missing some centers, and they're also suffering from angular distortions. So the tree of life structures aren't capable of aligning from one level to the next. Because of their missing centers and their distortions, they're not capable of aligning properly from one level of cosmic structure to the next. Also, if we take polarized the party cum and party k polarities and attempt to overlay them, this Katara grid structure,